Hello everyone and welcome to Epista Life Science webinar. This webinar is part of our case series, and today we'll be talking about data integrity assessments. More specifically, I would like to introduce a risk-based approach that you can use to systematically assess your systems for data integrity gaps, as well as identify suitable mitigation measures for those gaps. My name is Hannah Greiner. I'm a senior consultant at Epista Life Science and really excited to share my thoughts as well as my experience on the topic with you today. First of all, 2 points for housekeeping. So we really love your questions. So please ask all the questions that come to your mind throughout the presentation in the chat section. I will try my very best to answer as much as possible at the end of the session. And for those questions that we unfortunately can't answer due to time, we will be reaching out to all of you after the seminar and get in touch to answer whatever is left. If there's of course any questions that appear after the webinar, please feel free to also just reach out, contact us. You can find all the contact details at the last slide of this presentation, as well as of course on our homepage. Second point, this webinar is recorded, so you will all receive a link after the webinar is over where you can then log in and re-see the webinar. So with that, just very briefly, Epista Life Science, for those of you who don't know us, who are we? We are a consultancy that's dedicated to continuously improving regulatory compliance, and we love sharing our knowledge basically whenever we can. So that's also the background for this case series and today's session on data integrity. The agenda for today is, first of all, going a bit into the background. Why are we taking up this topic? Why are we talking about data integrity assessments? Then we're going to be going over to how to get started with your data integrity assessment. What are the things that you need to think about first? Then I will be introducing the systematic approach that we have been developing. And then also go into how can you use this assessment approach to then actually define your mitigation strategies. And last but not least, I will also be sharing the experiences that were made with this approach during an authority inspection that was focusing on data integrity. So data integrity is a topic that has become really popular, and everyone started talking about it in the last few years. If we're actually looking a bit at history, the requirements for electronic records and signatures have been out there for way longer. So around 1997, where there was the first publications of that. Still, for the pharmaceutical, biotech, as well as medical device industry, paper records kind of remained the choice of documentation, probably because it was pretty easy. There was a lot of processes, procedures around, a lot of paper that was printed from all the computerized systems. And this approach was also very much accepted during any audits and inspections, and everyone was fine with it. Was until serious data manipulations were detected during inspection, when an inspector was actually looking at the electronic records and comparing them to the paper records that were available on site. And that then actually changed the whole situation, and data integrity was talked about by everyone basically and became the hot topic. And I guess a lot of you have also experienced that, that at some point, probably around 2015, 16, 17, you haven't come across that and your manager has asked you, okay, so where are we? What is it? Is that a critical topic for you or for us at our next inspection? So what do you need to look at when you get started looking at your systems and the potential data integrity gaps that you have? So first of all, you will look at your high-risk systems. This is what you will be asked. Okay, where is our risk? Where do we need to mitigate? Which systems do we need to exchange? Do we need to upgrade to make sure that we are safe during an inspection? But what is it? What are your high-risk systems? When asking that, companies typically, the answer is, well, data processing. As soon as we have a system where a user can actually process data, or we have dynamic data, then this is a critical system, and we really need to look at that. When going deeper into detail, you actually then sometimes realize, well, but what if that system actually has a full audit trail? What if all the modifications and processing that is done by your user is traceable? Is this then really your high-risk system? Do you need avoiding having any of those systems, or is it maybe not? Another popular answer that I've gotten is user management. A system is considered high risk if you have admin rights in the operational department. So that's a no-go, and then we definitely need to first start working on that. Again, the question is, what if your admin rights do not equal enhanced system access rights, as I would call them? Not all systems have very sophisticated user management hierarchies. So maybe you have a function that is called admin, but what can that admin actually do? Is whatever he or she is allowed to do in the system actually that bad? Or is it something that, yeah, he has more rights, but in the end, it's not really jeopardizing any of your data integrity? And again, what if everything that you have is traceable by an audit trail? Is it then really your high-risk system? When going into that, we're talking a lot about audit trails. So yeah, clearly some people say, well, I have a system that does not have an audit trail. So then that system must be high risk, right? Again, the question is, well, what if your data is static? If there's actually no real way to interact, modify, or change your data, if you can't delete it, is it then really, even though it does not have an audit trail, your high-risk system, or is there other systems you should be looking at first? Another good example is data storage. Some people consider systems where you store data locally as high-risk systems. But then when going into the details and looking at that system and how it's set up, you might have a system that has a set storage path, so you can't change the data is always going to be stored in the same location, you can't modify it, you can't delete it, you're having a backup that's regularly running. Then again, is that really high risk? So the challenge that normally comes up with this really, really simple question, what is a high risk system? Where do we need to first look at and mitigate? Is actually a more complex question, but it is crucial. So why is it so crucial to define or classify systems as high risk, medium risk, low risk, or at least have some sort of risk ranking between your systems when we are talking impact assessments and mitigation definition? The background for that is that if you don't do that, if you have all your systems and you say they're equally risky, then you're also more likely to develop generic mitigation strategies, meaning that you have a strategy that says, well, all our systems must. The problem with that is that all your systems are not going to be the same. So some of the systems that you have won't need all the controls that you are defining. And if you're setting up those generic strategies, you're typically putting a very, very huge burden on your operational departments. You're creating complex processes that they need to work with. And thereby you actually making them more error prone, or even worse, you're encouraging your operational departments to actually bypass and develop workarounds because they say, well, we can't keep up with all of that. What is an example for something like that? I have seen companies defining, and that's tying into the slide before, requirements like all admin rights must go to IT. The IT department is independent, that should manage everything. The problem that you will soon run into with that is if you have, for example, very simple equipment, you might have a scale in your laboratory. You have an admin for that scale, but all that admin actually does is change the time twice a year. So the question is, do you actually really want to have your IT staff walking around your laboratories twice a year to change the time, or is that a bit of an overkill? Same goes for manufacturing equipment. You might, with some equipment, have admins that are required to quit alarms. If you're not running a manufacturing that's running 24/7, that would in parallel mean you need to have your IT staff present 24/7. You would need to be able to call them. They need to, if it's a clean room setting, to go through gowning, probably not the expert in clean room, just in order to get in and quit alarms. So that's not really what you want to set up. Another example is data must not be stored locally. a nice general generic mitigation strategy for data integrity. If you're now not in the lucky position that you have a very, very new facility and everything has super high-tech new equipment, you will be having certain systems that are standalone. So what do? Can't use any of that anymore. You need to throw out all of them, even though the equipment as such is actually working well. Also, if you are actually having a site which is having a very brand new tech system, you might have systems that have a wireless connection to a server, which sounds really, really great. You're not storing anything locally anymore. But I've actually seen two sites who had the same system for clean room monitoring. The one had the system set up in a way it was storing locally. The other site said, no, we're not doing that because we want to prevent that. Both sites were then experiencing connection loss, and the one company or the one site that had the data stored locally was in a bit of a better position because they could at least retrieve that again and reestablish the connection. For the other site, the data was lost forever. And there was, of course, then a lot of mitigation, deviations, kappa measures around. So that is also something that should not be set as a generic mitigation strategy. A second reason as to why not go for those generic mitigation strategy and actually define how risky is the equipment or systems that we have is inconsistencies. If you are looking at the slide before, you will see that you will soon realize, okay, those generic strategies that we have are not working. So what a lot of companies are doing is setting up rules like all systems must do this and that, except, and very popular, except there's another justification in place that says they don't. So that is, of course, in the one hand, a valid approach because some of your systems don't need all the controls that you're setting and defining. But on the other hand, you also want to make sure that comparable systems have the same controls. So if you don't really have a clear definition of what is a high-risk system, how to mitigate that risk, you will force your operational department, your shop floor, to actually assess and define, okay, do we now have to stick to the general rules we have for those high-risk systems, or can we actually do it differently? And ultimately, that can lead to different departments or different sites or different organizations in your company to treat the same equipment or the same, let's say, data integrity risk that you have in different ways, which then can become troublesome if you have an inspector that's actually going through more of those departments, organizations, or sites and sees, well, here you're doing it differently than at the other place. An example for that, again, audit trail review. So all systems must have an audit trail review unless specified differently. Nice requirement. So you might have a department that says, okay, we have a system that does not have an audit trail. So we are exchanging that. So it is a requirement, we must have an audit trail review, so we need an audit trail review. Another department might interpret this as saying, well, unless specified differently, we're just going to say, well, we don't have an audit trail, so, well, we're just not going to do the audit trail review. Same goes as for the content of your audit trail. Not every audit trail is equally good. Some systems have a log that logs a lot of information, but it's not really useful for you. So one of your teams might say, well, we are still reviewing that because that's what we're supposed to do. The other department might say, well, no, we're not, because we're not getting the information out of that we want. So again, you have your inconsistency there. Same goes, just to add another example, for static data systems. Might be a justification to say if it's static, not reviewing. Others might say, well, I am, because the general rule is if I have an audit trail, I am reviewing it. This brings me now to how to define what is actually high risk. And in order to do so, I have found that having this two-dimensional structure where you go into data criticality combined with system criticality to be a good indication. On the one hand, you have a ton of data that's being generated. And just to set the scene here, what I am, of course, focusing on with all those data integrity assessments is GXP data. So I'm not necessarily looking at any non-GXP data here. But even if you are looking at your GXP data, you might have some data that is directly used for your batch release, You might have data that's supporting batch release, and then you might have GXP data that's not really related to batch release. And based on that, you can also define your criticality, saying, well, if it is actually going into a batch release decision, that data is a bit more critical. I need to first look at that data before going for data that's not actually affecting my product quality. The second dimension to look at is the system criticality. So do I have a system that only has minor data integrity gaps? Do I have major data integrity gaps? Or do I have critical data integrity gaps? And based on this, you can then easily say, where do you put your focus? So really focus on systems that have critical gaps and that are generating critical data for you. And then sequentially go down to your lower risk systems. So first dimension, critical data. That's normally already the first hurdle, first difficulty. How do I find out what my critical data is? I would personally say that the assessment as to how critical your data is something that probably a quality assurance department or regulatory affairs needs to do. But basically someone that knows your business, that knows how the data that's generated will be used and how that ultimately impacts product safety and efficacy. So it does not make sense to necessarily ask your system expert who knows how the system works, how the data is generated, how critical his data is, because it will ultimately just depend on what that data is going to be used. Will it be put into a submission? Will it be put into a COA? Is it something that someone just wanted to get in order to figure out if this is has a business value for the company to look into that a bit more? What is the actual reason that you are creating that data? And when you do that, and it doesn't matter where your data actually comes from, if it comes from quality control, if it comes from manufacturing, just ask a few questions. Ask, what is it going to be used for? Do your business analysis actually for your equipment. And of course, you might have equipment that creates two different sets of data, but then unfortunately, you will always have to go with the more critical one. But try avoiding general classifications like all GXP data is equally critical. That is something that will just, as mentioned, put a huge burden on what you are doing. It will prevent you from actually prioritizing which systems to first focus on and where to actually mitigate first. Also try generic classifications like development data is not critical. I've heard that one a lot, but if you then actually follow the data and see where does it end up, you will figure out that a lot of development data is going into submissions. You are using it for label claims, so saying my product has this stability, it can withstand this temperature, can withstand this humidity, and sometimes you are using your development data to also back up some qualified person decision or release responsible decision. So they're going to call you and say, well, we have this kind of deviation in temperature in one of our warehouses, so can we still use that or not? So someone might be looking through development data and say, oh yeah, we have some data on that. It is actually stable, and that is then passed on. So be careful with looking at your data, assessing what it's going to be used for. So, second dimension, critical systems. When looking at your critical systems, there's of course a lot of things you can look at. There's a ton of regulations, guidances, position papers on that, and if you read through all of them and try to do a comparison against all of that, you're going to be busy for long. But really try, when you look at the criticality of your system, to focus on the two most critical gaps that you can have: data loss and data manipulation. And in the end, it doesn't matter if that is happening intentionally or unintentionally. You might lose data because you have system, computer, or power supply crashes. It could be because you have a system that's not automatically saving results, and then someone just accidentally forgets pushing the save button. It could be something where you have actually access to any hard drives, if you have central storage locations, backup service, if you can access and delete data there. And also for manipulation, a lot of people think it's very much around changing the outcome of a result, but it could also just be giving your file name or giving your file a wrong name. And with that, you're making it untraceable again, because your file name is actually how you link it to a batch. Or you are actually processing your data and you just can't trace back to the original set of data. So no one can actually, in the end, go there and say, okay, this is what you started with and this is what you have been doing, so this is how you ended up there. If you can't prove how you did that from your original data to the end result, well, then you have a potential data manipulation because no one can verify that it's correct. You could also just have simple mistakes like faulty data transfer. If you're asking your operational departments to take paper records and then transcribe that into an IT system or vice versa, of course that is something where just mistakes can happen. So really try looking at those critical gaps and make sure that your systems are compliant by design rather than procedures. Of course, you can always say, well, you need to follow this process, this and that can happen. But in the end, if you are making sure your systems are set up, configured in a way that these data loss and data manipulation possibilities are decreased, you are doing your operational departments a huge favor because they just can't be wrong. So they can just work, do what they're best at, and don't have to worry about, oh my God, I forgot this and I accidentally happened to overwrite a file because I did not change the name and the system is just not designed to pick a new one, but it picks an old name and so on. Try really to make life easier and avoid those mistakes that can be easily avoided. So enough to the background as to how to get started and what to think about before you are actually going to your shop floor, you are looking at your systems and doing the assessment. But when you do, and this is now coming from our case study here, the idea was to develop a systematic approach that you can use for computerized systems independent of where they are coming from. Again, it could be quality control, could be manufacturing, and then to have one harmonized template that you can use to assess them. Of course, that template should include all the requirements that you get from FDA, from EU, WHO, PICS, whatever, you name it. Those are the regulatory requirements that you are working with. And really have this one template to increase your efficiency, but to also decrease complexity, because everyone knows that, okay, yeah, this is what we do and this is how we walk through. The important idea behind our approach was that once we identify with these assessments a gap for one of our systems, we wanted to have an automatic risk rating. So now, okay, what does that mean? Is that now a critical system gap? Is it a major system gap, or is it a low system gap? And based on that, then define a risk-based mitigation strategy. And again, that should be something that can just be coming out of that approach to increase efficiency and decrease complexity. And just to make everything more easy, we wanted to develop an approach that was really guiding the user through step by step and could be executed by system experts and not necessarily by your QA department. So what we did, and what probably a lot of you know, is we started out with an Excel gap assessment. And this is just a fake example, but probably some of you will recognize similarities. So you are listing all your computerized systems. You then have tons of columns that are added to that, and there you are asking questions. Questions are management, audit trail, whatever you want. In the end, you then have a column where you do a risk rating, say, okay, this is now high, medium, and low. Most of those files then in the end have a comment column as well. So that's where then users can put in some additional information. So what is the problem if you go for a gap assessment like that, and why did we not end up doing that? So the first one is phrasing the criteria. In order to have a good overview of your systems, you kind of want to have yes in your system or in your Excel file to always indicate that's good. Does your system have an audit trail? Yes, that's good. But when you are phrasing your criteria, you sometimes are coming across, can I delete data? Yes. Well, that's not good. So you're actually ending up, and it might sound like a simple problem, but in the end, you started with phrasing really, really strange questions in those Excel files just to make sure that the answer then matches the outcome that you want to have. So yes being good and no being bad. Second point is you will, with most of those assessments, get your system experts to answer with yes or no, but. So if you're unlucky, they're actually going to write all their text into the field. So that really messes up all your filtering that you want to do, all the evaluation of the data you've collected. or they are adding a lot of information in this column, comment column. So they will say, yes, the system has an audit trail. You are reviewing that, say, oh yeah, that's great. But then you see in the comment, well, but it's a useless one because it is not logging this, it's not logging that, it's not giving me that information. Or, I don't know, the audit trail is deleted after 2 days. So it's something that is really, really hard to assess in this Excel gap assessment format that you do. The other big problem that you typically have those gap assessments is that if you really use one for all of your equipments and systems, you will figure out that your simple equipment has a lot of no's in there. Does your pH meter have an audit trail? No. Does it have a user management, free user hierarchies? No, it doesn't. So that then ultimately leads to the question, well, if I now have a system that has all those no's, is this then the most critical system that I have? Or is it in fact in a way that the no's are not equally bad? Or is it sometimes just related that you say, I might have a no here, but if I, on the other hand, have another no or yes in another column, well, maybe that then kind of like compensates and it's not that bad in the end. So how do you rate those different no's and yes? And how do you, in fact, assess the comments column? What normally then happens is that people do a manual risk rating. So they fill everything out, and then you have a system that has 90% no's, has a low risk, and then you have one that has 2 no's and has a high risk. So in the end, it's not really helping you that much, again, if you want to have a systematic approach. So we went away from that and we're looking towards a decision tree. So our idea was to actually ask a question, just like the gap assessment would do, but then based on the answer that you give to that question, you're going to be redirected to another question. And that question will be different than the question you would be asked if you answered in a different way. And that way you can actually walk down and figure out in the end if you have a system that has a low risk, has medium risk, or has a high risk. So given a few examples of that. Again, these are just snips out of a tree. So there's a lot of paths, of course, left and right, and there's also maybe some questions in between, but just to give a bit of an idea. So here, first example, very simple equipment. We have a system that creates electronic data, but does not, the question is, how is data stored? Is it permanently in a hard drive or is it temporarily stored on a ring buffer? So, oh, okay, it's a simple equipment. It only has a ring buffer. Okay, then the question is, okay, can we somehow transfer that data? Can we connect it to any system that we have? Well, no, we can't. It's a standalone system. Then the question is, okay, do we have any chance of accessing that data that is stored in the ring buffer? Can we somehow log into the device, or can we print it out? Is there any chance for that? No, in our case, said that's not possible. It's just showing that. Then the next question would be, okay, so then it's just showing that I have no chance of accessing, I have no chance of extracting the data. Do we then have a 4 eyes control in place? Yes, we do. Okay, then that system is low risk. It might not be the nicest one. It's a lot of burden that you have with it, but still, from a compliance perspective, you can do that. And then if you say, no, we don't have a 4 eyes control, well, then it is a risky system that you have because you can't really confirm the data that you got. Looking at another example, and you can see that's a bit more complex, we are now looking at a system that is permanently storing data on some sort of hard drive. Okay, next question is it a local one or is it a central one? So, well, our system has a central storage on, for example, a server. Okay, then we look at, is there any chance that there's actually a potential data transfer? How is that looking? Then we say, well, no, actually not, because we are having an interim storage on the system. And if there's an interruption, as soon as it reestablished, the data is pushed on. Okay, good. That sounds really nice. What about the file or data access then that we have on our central storage location? Is it possible in general? Is that just a P drive that I have that everyone can just go to? Or is it something where I say, okay, that's a protected one, I can only access if I actually log in with my device and then open one of those files? Oh yeah, okay, so our system has that. Then the next question is, how can I actually, when I reopen that data, when I access via my system, can I modify or delete the data. If I say, okay, I can access it there, but I can't delete it and I can't modify it, well, then that is a system that has a low risk. On the other hand, if I say, okay, I have a system that can actually allows me to open up this file or data that I have stored centrally, and then I can modify it again, well, then the question is, how's the data processing looking? Is it something that's done individually by a user, or do I have some predefined control method? So it's basically just a click where they say. Well, in our case, we now say, that's actually done individually by a user. Next question is, how's it looking with our audit trail? Do we have something? Say, well, we either don't have an audit trail, or we can turn the audit trail off, or we have an audit trail that's not comprehensive or not archived. Either way, if we have that, well, then that's a high risk system. And we say, okay, we actually do have our audit trail though, and it is comprehensive. We get the information out that we want to. Then the next question would be, okay, do you then ever look at that? If you do, okay, then you're fine. Don't put your focus on that system first. If you don't, well, then an easy fix would just be implementing that. But you are having an issue because your audit trail is just tracing it. If no one ever looks at it, you're not going to be identifying any data loss or manipulation that you want to have. And then I have a third example. I mean, in the end, it's again just showing you how to walk through, also dealing with questions where you say, okay, you have your system that you go through. You're actually also dealing with printouts. You'll still have those simple equipment where you're not able to access everything automatically. Okay, how are you doing that? Is it an automatic one? Is there a chance if you're not having it automatically that your user forgets printing it? And then, yeah, you have a problem with your reconciliation. If it is automatically printed, still the big question, are you reconciling it or are you not? So this is just basically how you walk through. And again, it's just little snips out of the big tree, but this will actually guide you to the questions that are relevant for the system that you are looking at. You could be done, like in example one, really, really quickly. This was just 4 questions that you have to answer because it's a very simple equipment. If you go for a more complex one, well, then you have more questions to answer, but there's also more information that you need in order to figure out, is this now actually a data integrity gap that we need to look at or not? So we were pretty happy with going through the decision tree for various reasons. So what is the big benefit? Well, first of all, it's the workflow structure. And I felt people are actually way more happy to go through a workflow rather than those huge Excel tables with, I don't know, partially 200, 300 columns that you need to fill out. So you can actually use that workflow structure to hand it over to your system experts because they have the questionnaire. You of course need to make sure that everything's set up in a way that they understand the question, that they understand the answers, so they can make a meaningful assessment. But in the end, you don't need anyone to guide them through that one. The other big benefit that we saw with that is that you have an automatic risk rating. So the risk that you receive in the end is really based on the answers that you give upfront. It's also by doing so weighing the questions or the answers that you are giving in a different way, saying, okay, depending on everything that you have said before, we are weighing this answer, well, more severely or less severely. And in the end, there's also no cheating possible because, yeah, if you answer the questions and you go down, you will end up with a high, low, or medium risk. You can't just say, well, okay, I have a few gaps here and there, but in the end, I'm still going to be entering low for my system. It's also really just looking at your system gaps. You're completely taking out the discussion for your data, what kind of data it's creating and how that's going to be used. So this is really how safe is your system in terms of data integrity. And last but not least, the really, really big benefit is it's easy to explain. So on the one hand, to the shop floor level, so QC staff, operators in your manufacturing lines, people understand the approach. Management understands the approach. It's logical. If you say to them, okay, here we have a high-risk system, and they ask, well, why is that a high-risk system? You say, well, look, this is the questions we asked, this is the path that we went down, and in the end, we ended up with a high risk. So it is very transparent in that way. And of course, because it's easy to explain for shop floor management, it's also easy to explain to inspectors and auditors. You can say, that is the reason that we prioritize mitigation for this equipment over the mitigation of that equipment. Now, to the disadvantages, because we are honest here. Every approach, of course, also has its disadvantages. Looking at the decision tree, the probably biggest disadvantage is the workflow design, which is also its biggest benefit. But you need, when you are initially setting up this decision tree framework, you need your system and your compliance experts to work together to actually phrase meaningful questions for your systems. So the workflow in the tree should reflect actually the systems that you are working with. There's no point in having branches down your tree that you will never go down through because you don't have equipment that kind of like goes into that. But it very much makes sense that you are setting up in a way that it does cover all your systems. So that's the tricky part. Also, because it is a decision tree framework, and based on an answer that you give, you will be redirected to a next question. It's not easy to add questions later on. Whilst in your Excel gap assessment, you can always add another column with another question and then just answer that. You can't do that with a decision tree, because if you pull in a question in there, well, then you will have at least 2 different answers that you can give. So that changes the whole structure for you. So you need to be sure when you are setting it up, saying this is now a decision tree and that's the framework that we are going to be assessing. If you are assessing 5 systems with your tree and then you're expanding it and you're changing everything, well, then you got to redo the ones that you already assessed. So that's why you really need to look at having this first time right approach, making sure that your tree is solid when you get started, because you just can't easily add the questions afterwards. Second one, something that I, of course, hear a lot. Again, you've not seen the full tree, but even if you did, it's not that everything is going to be covered in that one tree and all the questions that you have. So there's a lot more to it. So when we are talking audit trail review, of course, you also need to think about what is your audit trail review frequency? Do you do that every 3 years? Well, then it's probably not a good mitigation measure that you have. So we really tried with setting up the tree, because it is a big tree, it is massive, it is complex, to focus on data loss and data manipulation. So those were the key gaps that we had, and we said if the system allows that, then we have a critical gap. Everything around backup intervals, review intervals needs to be looked at, of course, but that is outside of the general system design part. So coming to the next really important one. So a lot of companies have done assessments. They said, okay, these are our systems, this is how we rate them: high risk system, medium risk system, low risk system. But then the actual really tricky part starts. Well, how do you define your mitigation strategies? You can't just go to an inspector and say, oh yeah, I know that system is not really good, it has a lot of gaps. You also need to make sure that you have a plan available and that you actually also stick to that plan actually of how you're going to be closing those gaps. So the idea is that because you will not be able to change the data criticality, if you have a system that creates or generates data for a batch release, well, it will still do so even if you change the settings of that. So you can't change the data criticality. But what you can do is you can close your data integrity gaps that the system has. So then you can just move down from critical gaps to major gaps to minor gaps, and hopefully at some point also to no gaps. So coming back to our tree, the schematic of that, how do we use that tree now to define our risk-based mitigation strategy? The great thing about this tree and all the questions is that you always, when you have a question with a certain answer, you have the possibility to impact. Because at the moment that I change the answer to my question, so I change my system design, my system configuration, then I'm being redirected to another question, and then ultimately to a different result. So that way I can easily identify, okay, what am I going to do to move my equipment, which was here on a high risk, to a medium or a low risk? One example. So we have the initial situation, and again, a bit abbreviated here. We have a system that has a permanent central storage. Access to the data in the file is only possible via the device, similar to what we looked at in the assessment before. We say the files and the data can't be deleted, but they can be modified. Data processing happens individually by the user though, and we either don't have an audit trail or it's possible to turn off, it's not comprehensive or not archived. Okay, so now what do we do about the system? Easiest and probably most obvious choice for most people is, well, we need an audit trail. So either you upgrade your system, you activate, sometimes it's available, just not activated, your audit trail. So if you then say, okay, now I have an audit trail available that's comprehensive, that I can't turn off and it's archived, well, then you are automatically moving to the next question. Okay, then do you have an audit trail review? And if you say, yes, we are implementing that, well, then congratulations, you just moved your system from a high-risk system to a low-risk system. You also have the possibility, though, to go a step higher and say, what around data processing? Is it actually possible to exchange or upgrade the equipment to go away where you only have predefined methods? So they're pre-proofed in the system and then you just select them and then the data is processed accordingly? Well, yeah, if you do that, well, then, and again, going here to paper printouts, that was the specific case that we had. If you are then having that and you're printing it out, do you have all your information on the paper? Do you do reconcile the paper printouts again against your electronic files? Well, good. You moved your system to a low-risk system. If you don't have complete printouts, well, do you then actually review your electronic files and that information that you don't have available on paper? You do? Great. You have a low risk. Or you actually go to the top. You say, can I somehow change my system in a way that I say I can't or don't need to modify my data? Well, yeah, then we are going down a completely different path. The great thing about having a tree like that, having the assessment and doing the mitigation strategy definition based on that is that you can use that. So if you are in a situation and you have your high-risk system and you can talk with your system expert and say, okay, we have those different possibilities to move it to a medium or low-risk system. And then they can themselves decide, okay, what is actually doable, what is possible, and what do they want to do, how much effort do they want to put into that financially as well as resource-wise. You're also in the really big advantage that you have several mitigation strategies that are visible at once. So you see the scenarios. You can't just say, okay, if we impact here, change the answer. Well, you're immediately on a different branch, and then you can just walk down that. And that allows companies to then really go for what is a reasonable approach and not just the obvious. There's very often a lot around 4 eyes controls, review of data, rather than actually looking at the original root cause that causes you to actually go down this whole branch and cause you trouble and say, well, is there actually a possibility to change things on a higher level to already prevent us having all those discussions downstream? So that is something that is really nicely to be done with this decision tree. And then again, you can explain it easily to your shop floor, to the management, as well as to inspectors and auditors. You can say, okay, why did you take this measure and why didn't you take another measure? Well, look, here's our tree. This is why we chose to go that way. It has the same result ultimately. Disadvantages, and this is basically just a copy paste from before. You need to have your workflow. Again, we are focusing on the biggest gaps. But the good news is, if you have created the tree and you use it for your assessments, then you can right away use it for your mitigation strategy definition as well. So you don't have to do that work twice. So last but not least, a lot of talking about approaches, but how did that actually come up, or how was that viewed during an authority inspection? Because of course, it's nice doing all those activities, but in the end, we want inspectors that when they come on site to not say like, well, you know, was a good effort, but I don't agree with it. So, bit of a background. So the inspection was conducted by the Austrian Agency for Health and Food Safety, also called AGES. And maybe a bit to the background. So the AGES was one of the first 8 EU agencies that was approved by the US FDA as part of the Mutual Recognition Agreement in November 2017. I can't prove that there's a relation between that, but yeah, ultimately, really recently after that, beginning of 2018, the AGES launched a computerized system inspection initiative, meaning that they actually had their own department within the inspection department that was focusing on computerized systems and data integrity. And they were then in 2018 starting to conduct dedicated and separate computerized system and data integrity inspections. That mean that you would still have your normal GMP inspections, you would still have all the contact with the agencies and their inspectors as you normally would have. You would just have, at least once during that year, another appointment with this computerized system inspector who was actually only looking at your computerized system and data integrity. So from this case study, we were faced with a 2-day on-site inspection of a pharmaceutical site that was doing pharmaceutical development as well as manufacturing. It was one inspector from this computerized system department. And we had just been implementing this decision tree approach a few months before in order to assess all the existing QC as well as manufacturing systems that were used both for development as well as commercial activities. So what were the key takeaways after the inspection? So we were able to go in and present the approach for assessment and mitigation, as well as prioritization of mitigation right after the introduction meeting to explain how we're working on that topic over the past few months before we were actually going for the site tour, so before the inspector went to see the systems. When we had ended the 2-day inspection, we got very positive feedback from the quality team as well as the shop floor because they said, well, it was actually easy to explain what we're doing, how we're doing it, and why we're doing it. And also, whenever there was when the inspector was pointing out for a system like, okay, so what are you doing here? And I see you don't have this and that implemented. How are you mitigating that? How's your mitigation strategy? It was really easy to just refer to that and say, well, this is how we assess our equipment. Based on that, we did prioritize our mitigation. This is our first focus. This is going to be the second focus. This is our priority. And that way there was not really a lot to criticize there, because we had the plan and there was a justification that was understandable. Also, and probably more importantly even, we got very positive feedback from the inspector himself. So he was really impressed by the comprehensive approach that we had developed and also of course then executed. He also admitted that he had never seen anything like this before, and he took some copies. He liked that approach. And overall, the conclusion was that he was actually, or the approach sounded so good to him. It seemed sound that he was actually, whenever we were pulling out that tree and said, oh yeah, listen, so this equipment we assessed with this and that, he would not go into too much detail there. And he was like, oh yeah, okay, I understand that's your approach, that's nice. I mean, ultimately he wasn't looking at systems that we had not yet assessed, so you can think yourself if that was good or bad. But overall, it was really that there was not any big findings that were related to the approach that we had, the prioritization or the strategy. Of course, you will always, be explaining why you don't have certain things, and there will be notes down to that. But the approach as such was something that really helped us a lot to go through that inspection and to also present a common approach across all departments that we had, whether it was development or it was commercial. So that brings me to the end, and I think very well in time as well. So I can see that we have actually some questions there. And once more, we will be reaching out if we're not able to answer all of them, which I sadly won't be. And also if there's any other questions that come to your mind afterwards, or you've not had the chance to put them into the chat please really send us an email, give us a call, and we're happy to follow up with all of the questions. One that I can see that seems to have come up a few times is the question. So you're talking a lot about QC and manufacturing equipment. Can the approach also be used for pure computer system? So yeah, of course. So what I've been trying to present today is a framework, is a general approach, a bit of a mindset shift, like let's say, away from the traditional gap assessments. But in the end, I mean, the way that you design your tree, the kind of questions that you ask as such should match whatever you want to assess. If you want to use it for pure IT systems that are not related to your directly related to your manufacturing or QC equipment, well, then the questions will probably be different. But still, you can use it and you can create that tree and assess those IT systems. So there's no problem with that. Then next question: how big was the tree? The tree was big. It was a lot of effort and a lot of work that we put into that. And I'm happy that we actually had the time to really phrase it out. So it was definitely nothing that you could print, not even on a few A3 format pages. So what we basically did is that we had one, let's say, overview tree that was kind of like showing the major branches, if you want, and then we had kind of like the subcategories for the branches below. So you could, with the first few questions, kind of like say, okay, now I'm following tree A or branch A, which leads to the subsequent tree, and then B, C, and so on. But it actually was a pretty huge tree that we did set up there. Okay, I think I have one more question that I can answer. So how long does it take to go through the assessment? That's, I would say, a difficult question. It will very much depend. I mean, one thing is, if in theory, if you have the tree set up, you're half the way maybe. Yeah, you've set your framework. That's a lot of work. Then if you have to go through, and I mean, also with the examples, it probably sounded really easy, but there's quite a bit to the questions that you ask. Like, what does data modification actually mean? You need to be precise for your people when they go through the assessment to actually know, so someone doesn't interpret it differently. So if you're going into that, you need to make sure that that is in place, that people understand it. And then when you actually know how much there is in the background to what might sound like a simple question, it comes a bit down to how well do your system experts know their system. So what I experienced, which is actually a good thing, is that if you ask people, okay, so how can I trick the system? Is there any chance that I can, modify data so it won't be caught by the audit trail? They often don't know, because I mean, they don't want to do that. They don't want to manipulate their data. They have their SOPs, their procedures, their methods, and that's how they operate. So very often they weren't quite sure what you could all do. So then it became a bit of an adventure, trying to see, okay, what can we actually do? Where can we challenge the system? So that's definitely a bit of an aspect of how well you know your systems. And then it probably also comes down a bit to the maturity of your documentation that you have around, because normally, or hopefully, you would be able to find the answers to well, at least a lot of the questions in your validation documentation, right? You would be able to see, okay, this is how it's set up, this is what's possible, and so on. If you're not that set there, if also maybe your IT structure, the IT backbone that you have, with all the backups and all the networks that you have set up, if that's not that mature, and you need to look into that individually for each system because it's not commonly set up, well, then it takes more time. So yeah, I guess it's not directly answering the question, but it's a difficult question. It will depend a bit, but yeah, it's something that I would definitely say is worth the effort doing, because then later on for your mitigation and the prioritization and explaining it, that's easy. That's something that you're not going to be struggling with that much. So yes, I think with that, I will wrap it up. Still, thank you so much for all the other questions. As mentioned in the beginning and just before, we love your questions. Please continue sending them even after the webinar if you have anything. We'll be following up in the next coming days to answer every question that has been sent. And yeah, if you want, feel free to give us a call, write an email, schedule a meeting. We're happy to give you more insights into that topic. And yeah, promised on the last slide, you have the contact details. You of course also find all of that on the homepage if you want to. And yeah, that leaves me with saying thank you for today's webinar, and I wish you a very nice afternoon. Bye.